1, 1, 0. 8, 8, 8, 8, 8, 9. Okay, so we see how easy it is. And this is just, by looking at this, you get the impression that, yeah, it really is very easy. All we have to do is learn what these numbers are. This set of numbers is the same set of numbers as this set, with the only difference, this goes one down from this one. Okay, and since all of them do that, then the whole thing, that triangle goes down by 9 in that sense. So I believe in order to do the trick, you just do this yourself, okay? You become familiar with what this little idiosyncrasy, what these little differentiations are. 2 is going to go to 3, 5 is going to go to 6, 3 is going to go to 4. We'll do 5 a little bit, 25, 3025, then 308025, then 3086, 358025, then 3086, 419, 358025. And once you do it yourself enough times, then you'll become comfortable with it yourself, and you will see how easy 5 is, and really how easy they all are. They really, that's the whole point. It's as easy as 3, 6, 9. So we've looked at them, and 9's as easy as that, and we can just go 9 squared is 81, 99 squared is 9801, 999 squared is 998,001. Then it goes 999,80001. Then it goes 99998,00001. Okay, that's that. Now, what we're going to look at now is how it continues on into infinity. Let me see 1 second. Okay, I guess we're doing okay. All right. So now we're going to look at the 2 number, and we're going to try and understand what is going on when it goes from the 9th to the 18th, because what happens there is going to happen with all of them. So here we have it again. They're going to make the 9s. So 4 and 5, 8 and 1, 2 and 7, 1 and 8, 6 and 3, 0 and 9, 5 and 4, and 9 and 0. There is a 0 there, actually. It doesn't mean anything on this one, but basically it comes in here. It's a 0. Now, we'll see that the same set of numbers is appearing in this and is appearing in this, but something changes. The only thing changes is this number, and it happens right here. So what this tells us essentially is this. If we have 9 of them, it will be that much. If we have 18 of them, this is going to go over here, this is going to be a 6, and this is going to go over here, and this is going to be a 5. That's all that's happening. This will go down here, and most of it will go here, but this will be 6, 4. Over here, it's 6, 3. So 6, 4 and 6, 3. With 5, it'll go 1975. Here it'll be 1974. That was that 1974, 1975 change we saw up here. We see it. 1974, but it turned into 1975 here going this way, and that's why it's down here. So knowing this, we can know what this is and what this is automatically. We can literally know from this what this is going to be and into the future, or into infinity, because it's going to end with this sequence. This is the ending sequence. This is the repeating sequence. So this is 18 of them. 18 5 squared. If we want to do 27 5 squared, we're going to get 2 of these, like the 10 numbers, and then it's going to end with that. And if it's some number in between, let's say 36 and 45, well, with 36 and 45, let's say it's 40. So 36 would be 3 of these, that's 27 of the 36. And then, well, okay, we have to get to 40. So 3 of these is 27, and then it's going to be 28, 29. Okay, let me do that again. this is 18. To get to 27, it would be 2 of these and 1 of these. To get to 36, it would be 3 of these and 1 of these. And in between 36 and 45, for instance, it would be another 1 of these, and then we use these to fill in like the end of it. So these are like the 10 numbers, and this is like a 10, and these are 1s. That's what I'm trying to say. I hope that kind of how it works for you. And you start to see all these kind of similarities maybe between the numbers, because you were noticing this sequence was in number 1. And the reason is because 8 and 1 adds up to 9. And 9 dictates the system, and we see it with the 1 right here. 1, 2, 3, 4, 5, 6, 7, and the 7, 9, 0. And with the 8, we got the 7, 9, 0, 2, and 1, 2, 3, 4, 5, 6. So it just ends a little bit differently. It ends 5, 4, 4. Instead of 5, 3, 2, 1. Okay, now we're going to look at some of these. We're going to break it down, and we're going to look at some of these numbers from different angles without spending much time on any of them, but we're just going to notice the similarities between the left and the right hand side of each of the numbers, the similarities between the numbers as they go up, the codes that are developed, and it's the 369 code. So similarity between numbers themselves and similarities between other numbers, but we see, for instance, 111 million and 888 million to the end. They're similar numbers. They have the same general sequence. There's something going on there. We can notice that. With 2 and 7, the same thing goes on. Here, the only thing that's changing is the order. This 4938270. And here it's 493827159, which becomes 4938270 actually. But anyway, between the 2 and the 7, we see that they're related numbers. And now we're going to do this. What we want to do is we want to look at the difference between 1 and 8 to 18. Okay, so now we're at, it's like the triangle that we're examining is this large. Okay, that's this triangle as compared to the smaller triangle. But anyway, we see the codes reoccurring. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 9, 0, 9, 0. 8, 9, 9, 0. 9, 9. So they're basically the same number, aren't they? And that's my point. Okay, so if we become more familiar with these numbers, these are like individual numbers. You will know that number, okay? Just like a 1 or a 2, this whole number right here, okay? Because that's in essence what they are, because it's the 369 code, and the 369 code goes 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and everything is repeating. And these groups of numbers represent one number, as a matter of fact. We see that in 4 and 5, what happens is this. This is 308641975, or 308641975. Same number, just a little bit of a different arrangement between the 4 and the 5. And here we see it. We just see something else a little bit of a different way. Okay, so this is the left side of the number, and this is the right side of the number. And the right side of the number is exactly like this. 802-469-135. 802-469-135. Look. 802-569-135. 802-469-136. Okay, so there's a little changing. Numbers change when they go from 1 to 2, but basically that's all that's happening. All right, 9 of them and 1 with 18 of them. What we're going to see is basically this. This is what you understand. On the left-hand side and on the right-hand side with 9 of them, this falls into this place, and this number falls into this place. And it will do them do that with all of the numbers. So just from a different angle, looking at it sideways, the left-hand side of the number is going to fall in, and the right-hand side is going to be what I call the repeating sequence. This is the ending sequence on the left-hand side. This is the ending sequence on the right-hand side, and this is the repeating sequence on the right-hand side, and this is the repeating sequence on the left-hand side. So if you know what this number is and what this number is, you will know how to do it with all numbers. Same thing happens. Now with 3, 6, and 9, they have always, with the 3, 6, and 9, it's a different kind of set of parameters as it is with the 2, 4, 8, 7, 5, 1. But anyway, this does happen. It goes to the right-hand side. It does on the left and the right. It goes from left to right, left to right. That does, but what we see here is we see the 369 code acting a little bit differently. It's going 369. Okay. With the 4, which is a 248751 number, we see these 6s and 3s on the top. With the 369 numbers, we're going to see 369 numbers on the bottom. But we're reducing these numbers, and here's one of these groups of numbers that I speak of. Okay, so here it is, 802469136. Well, that's going to give us a 369 number. It's going to give us a 3, and it's going to always be a 3, and 197530863 is going to be a 6. So the 6 goes down there, and the 3 goes right there. Okay, and as with the 4s, the 5s have 639 numbers at the top. So this is like a 6, this is like a 3. What do we get when we add 6 and 3? We get 9. Okay, so it keeps on giving us something that's easy as a reference. Okay, with 6, these are going to be 369 numbers on the bottom. Now, this group goes into here, this group goes into here to end. This becomes the repeating sequence on the bottom. On the right-hand side, this is the repeating sequence on the bottom on the left-hand side. So we'll just look at 7, and we see it does the same thing. And now we're up to 8, does the same thing. And of course 9 will do the same thing, and it's all very simple to see that. Okay, so we have to prove or demonstrate somehow that these numbers, they will continue on to infinity. So what I'm showing you here is when it goes 1, for instance, to the 10th, excuse me, when it goes 1 to the 10th, or 10 ones squared, it ends with this middle number of 89. Now, if you remember, 1 squared is 1, but here it goes to 0, 0, and this is how it does it. So it goes down 1 from 0, 1 to 0, 0, and it will always be 0, 0, and this shows you how it will do it. The 8 goes to a 9, and the 9 goes to a 9, and everything on the right-hand side is always what it was. But 89 goes to 0, 0, and that's what changes. And with 2, the 5, 9 is going to go to 0, 3, because 2 squared was 0, 4. 0, 4 minus 1 gives us a 0, 3, and it will continue on. It will always be 0, 3. And for 4, it will be 4 squared is 16, but in the 10th position, and in the 19th position, and in the 28th position, and the 46th position, and the 55th position, it will go like that. It will always be 15 instead of 16. And the same thing applies with 5. 5 squared is 25. It starts off with 25, but in the 10th position it'll be 24, 19th position 24. 27 plus 1 is the 28th position, then 36 plus 1, the 37th position. It goes on to infinity like that. So that's why I'm showing you that. That's to prove that it goes on to infinity, and that number we get there, that's 63. And what I'm doing is I'm showing you what is going to happen in this space right here. And this space right here is 10, and this is 1, and 1 squared goes to 0, 0, 0, 3, 0, 8, 15, 24, 35, 48, 63, 80. Instead of 1 squared is 1, 2 squared 4, 3 squared 9, 4 squared 16, etc. So now we're just going to kind of look at it, and we're going to break it down a little bit more, because what we're doing is we're breaking it down, and we're going to end when we get to the whole thing is a 9. But before we see the whole thing as a 9, we'll see all of these other groups of numbers as they reduce. So what we see is the 3, 6, 9. This is what happens on the right side. These are 9 numbers. Well, zeros is not. It's a different thing, but anytime you have the same numbers times 9, it's going to reduce to a 9. 8 times 9, 70 is 72. 7 and 2 is 9. 5 times 9, 45. 4 and 5 is 9. On the right side, it just does this 9. The 8 turns into a 9. The 5 turns into a 6. So by understanding that, you'll see how easy it is to do that. Now with the 2, 4, 8, 7, 5, 1 numbers, it's just as easy, and it reduces to the 369 code. Well, remember we said, well, what is the 369 code? It might be 258, 258, 258, which it is. It might be 963, 369, which it is, but they're essentially the same thing. You see, the reason why is because 3, 6, and 9. Okay, well, 1, 4, and 7 is the 369 code as well. It just starts at 1 instead of 363. And 258 is a 369 code as well. It just starts at 2 instead of 3. So that's why they're the same, because they're doing the same thing. In any case, we see how easy it is on the 369 numbers. That's a 9, that's a 9, and that's a 9, and then it'll go off by 1, because that's how it ends. But it's as easy as that. I hope you can understand what I'm saying about that. Here we have all of them together, the 2, 4, 8, 7, 5, 1 numbers, and this is how they end, and this is how the repeating sequence. So from this, if you understand and know what this is, you can write this, and this will take you into infinity, because the numbers are going to end like that, what they're doing here, but they're going to continue and do this repeating sequence like this, and they're essentially the same with only like one little difference in each of them. 5, 6 goes to 5, 5. 71 to 70, 75, 74, 64, 63, 60, 59, 790, 789. They just go down by 1. So if you know this, you know this. And if you know this, you know this. And if you know either one of them, you know how to do it forever. And here's another way to look at it, and you can see that the 369 code is appearing, because the repeating side on the right and the repeating side on the left both give us the 369 code. 149, 779, 419. Whenever we multiply numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, which includes any number in the world that reduces to 1, 2, 3, 4, 5, 6, 7, 8, 9, will behave according to that sequence. And here I'm showing you the 528 code. We get that as well. So the repeating side is giving us the other code, 258, 258, 258. Okay? Now, this 147, 779, 419, well, that's actually, it's 258 as well, because I can go 1 and 4 is 5, 7 and 7 is 14, is 5, 4 and 1 is 5. Okay, 5, 5, 5. That's not exactly what I wanted to say there, but I can make it 258. I know I can. How do you do that? I'm not going to think about that right now. I'm going to confuse myself. Okay, but we'll get to that, and I'll show you it in another way. So we get 149, 779, 419, 852, 258. The 9s, now, as long as they're in a position where they're, equidistance, you can see that they're not affecting the code. They're in order. This is the 369 code. Okay, that is the 369 code. Okay, so basically what I do is I take these triangles and we look at them. This is what these triangles do, as a matter of fact. One starts off with a 0, 1. Here it goes 0, 4, here it goes 0, 9, here it goes 0, 6, or 1, 6, 2, 5, 3, 6, 4, 9, 6, 4, 8, 1. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 81. That's following the 369 code going 149779419. Okay, so what exactly did we do? All right, so this is what we did. This is what we did. And now we're going to uncover the code and we're going to understand how the code works. Basically, these are triangles. These triangles, okay, so what this sheet of paper right here represents is going to be, it's not good to do it like that. I should show it to you like this. This represents these triangles. Okay? In other words, if I add up these numbers on the right-hand side, and I add up these numbers on the left-hand side, these are both individual triangles. Okay? And that's what this represents here. So I add up all of the numbers in each one of those triangles, and then I reduce them and I add them, and et cetera, and I get something that looks like that. Okay, so at first glance it may not look like the 369 code, but it is. If we add these numbers all together on the right hand side, it's going to go 669, 669, 669. Now we remember with the universal law of numbers, it didn't do that. It went 696969. Well, this is not the universal law of numbers. This is not the grand design. This is one of the designs that the grand design offshoot. It's an offshoot that the grand design gives us because the grand design gives us all designs. Now, on the right, it's 669, 669, 669. On the bottom, it's 669, 669, 669. Right down here, we even see it. It goes 369 if you add these numbers up on the right-hand side. And this is 396. It's the 369 code. And if we add up all of these numbers going this way, it'll be 3519. And if we add up all those numbers that way, it's 3519. And that's how we know how we got the right answer. And 3519 is 3 and 5 is 8 and 1 is 9 plus 9. It's a 9 because the thing is a 9. Now, that's adding them all up, all of these triangles with 9 through the 9th one. And this one is adding them up with the second triangle, or the extension of that triangle. Okay, so now I'm adding, this is through the 9th, and then we got 1, 2, 3, 4, 5, 6, 7, 8, 9 more, which is 10 nines, 11 nines, 12 nines, 13, 14, 15, 16, 17, 18 nines. So between 10 and 18, that's the second segment. It's the same sequence. It just has a lot more numbers in there. So these numbers will change. They'll become greater than the numbers of the first sequence, but it will follow the same code. Because if I add up all of these numbers on the left-hand side of the triangle, and then I reduce them all, I'm going to get 669, 669, 669. Down on the bottom, the same thing, I'm going to get 669, 669, 669. And it's going to add up to 10,080, and 1 and 0 and 0 and 8 and 0 is a 9. It's a 9. Now, if we want to reduce them like this, we can see that these codes start to appear. 149779, 419, very good. 479, 119, 749. Okay, in any case, they're going to give us 669, 669, 669, 285, 393, 405, 411, etc. is going to be 669, 669, 669. We are going to have down here all 81s, as you can see. Actually, this is the first one. I'm sorry, this is the first one, but it's going to reduce to the same thing. It really will. But the first one gives us 729. I showed you the second one first, the second triangle, excuse me. But you don't need to pay attention to those numbers. I don't think you can see those numbers, or I'd give you enough time to make much sense of those numbers. And I understand that. But either way, they will both reduce to this very same schematic. They will both reduce to the same exact thing because they are the same exact thing. And no matter how many times we go from 1 to 111,111,111 and make that 9 more ones and 9 more ones and 9 more ones and 9 more ones, it will always give us this sequences of numbers. It will always give us 669, 669, 669, 669, 669, 669, and that's the important thing. And now I guess I'm going to show you what I was having difficulty understanding a second ago. Basically, if we look at that and we get rid of the 9s, we see that 147 code more clearly. And the 147 code, as I say, it is the 258 code. Now, how are we going to do that? Okay, 1 and 4 is 5, and 4 is 13, and 7 is 20. That's a 2. 7 and 1 is 8, and 8 is 16, and 8 and 8 is 16. Well, yeah, they're 8s. Okay. 1 and 4 is 5. 4 and 7 is 11 is 2. 7 and 1 is 8. 1 and 4 is 5. 4 and 7 is 11 is 2. 7 and 1 is 8. 7 and 1 is 8. 4 and 7 is 11 is 2. 1 and 4 is 5. So that's how we get something that looks like that. So it is doing 258 if you look at it like that. But if we add them going across, 3 5s is 15, that's a 6. The 2s, 3 2s, 8s, that's what they did, okay? It goes 7 and 7 is 14, that's a 5. 1 and 1 is 2, that's a 2. 4 and 4 is 8. 8, 2, 5. 5, 2, 8. 8, 2, 5. That's how we get this one. And we see that that reduces to 6, 6, 6, 6, 6, 6. It's all the 369 code. That's the whole point of it. You see, the 369 code, these numbers have different personalities, and they're quite amazing characters if you think about them. Another thing about them is this. This has been going on since the beginning of the universe. What I'm talking about right here. But in any case, we can get 7s out of those too. 7, 7, 7, 7, 7, 7, 7, 7, 7 by adding them and reducing them. And that's what I was... And that's going to give us 3, 3, 3. But 3 plus 3 is 6 plus 3 is 9. That's the 369 code. So the 369 code, we have this triangle, that's the 369, and we have this triangle, and that's the 147, and we have this triangle, which is the 258, and the only thing that changes about them is their starting point. But they all exist inside of nature and inside of this structure, the 369 code, end as all numbers do. So what I'm going to do here is I'm going to basically point out that just like that sequence follows the 369 code, how other numbers follow the 369 code. So these are the Fibonacci numbers, and basically the Fibonacci numbers, it's like, it's the doubling sequence like Euler's number, but it allows for, the retribution. For instance, he used it for the rabbits. Well, the rabbits are multiplying as they do, but they're also dying off, and that dying off is what changes Fibonacci from Euler's number. But they're two very universal numbers. So if I do the Fibonacci numbers, they go 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, etc. And that's what we get. And we get the 369 code because we get 248751, which is 285 and 174. We get 181818. We get that too. 248751. That's the 369 code. 339669 is the 369 code. It's not the same exact one as the one we did with the numbers today. It's not the same exact one as with Euler's number. Euler's got his own. Euler's goes like this. This is e to the n, whereas n is 1 through 25. If we reduce the numbers, we get 157842, 157842, and that's the 369 code. It's 157842, 157842. It's the 369 code. So I hope people in the world learn something a little bit about the 369 code today, and basically what I want to do, oh yeah, I did. I wanted to show you that 729. Maybe I can't do that because it's going to be too much. Yeah. No, I have to have it here. Anyway, where is the universal law of numbers? It's not there. Okay, in any event, my point today is that this repetitive set of sequences that I refer to as universal law of numbers of 369 code is universal, okay? It's the code that dictates the whole arrangement of movement of numbers in our universe. And Pythagoras spoke of it, Tesla spoke of it. It's just a different way of understanding the numbers besides, here it is right here. Okay, this was when I reduced, and I get this. Okay, so the ninth position came to 729, and 729, it's the fundamental central number in the 369 code. Because basically what it is it's 9 to the third, okay? But in any case, all good people of the world, I hope you learned something today. Share it, use it. This is something that's very powerful beyond just being able to do simple, like mathematical numbers tricks. And I hope it provides you with a deeper insight of how things work in the number system, how things work in mathematics, how things work in science, how things work in music, how things work in art and poetry, etc. And I wish all good people of the world peace and happiness. But I also wish all good people of the world to recognize that this, hegemony that the United States is doing around the world at the bequest of Israel, we've lost our sovereignty in the United States completely to this infiltration by Israel, Israeli spies, ex-Soviet Russian Israeli spies,